Hey everybody, this is Larry. This is me over Q4 of the weekly contest 446. Find X value of array 2. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So this one is honestly a bit silly. If you're studying for interviews, I would just skip it. I mean, why bother? It's not a good use of your time if you're studying, in the sense that like you could just work on other easier basic problems that you struggle with rather than this one. But if you want to improve yourself and just have free time and maybe hate yourself, I don't know, and I'm just kidding, but if you want to get further on this and you want to play around with segment tree, definitely this is the way to go. I think, judging from the contest results, and there's a lot of cheaters anyway, so it's hard to tell. From what I understand, there are similar problems that people have solved, so a lot of top people solved it along with ChatGPT. But yeah, for this one, the prerequisite is a segment tree. I am going to go over segment tree in an elementary kind of way, in a surface level kind of way, but I'm not going to go over it in super detail. So definitely, yeah, you need to learn segment tree first, but I'll go over how I did it, right? So, okay. So first of all, let me bring up the drawing board as is customary for segment tree problems, probably. Okay, so what is a segment tree, right? I'm going to go over like a 2-minute overview, but the idea behind a segment tree, I think it's very easy to kind of look at implementations and be scared about it. I wouldn't say I was scared about it. I was just lazy about it when I first started about segment tree stuff. But really, there are some optimization with timing and getting it fast enough for Leetcode, etc., etc. But at its core, it is not that difficult in theory, right? So basically, you have a node, and on top there's your root node that goes from 0 to n-1, right? And then on the left node there is 0 to let's just say n over 2, and then right now we have n over 2 plus 1. So they don't overlap, but let's just keep them inclusive. You can also define them to be exclusive or whatever, but these are just notation, so you get it hopefully, right? And if I'm off by 1, you're smart enough to figure it out. But yeah, and then these are just 0 n over 4, say, and then n over 4 plus 1 to n over 2, right? And so forth, right? So that's really the way to think about nope, 3 over 4, maybe it's off by 1, but again, you get the idea, right? Like I said, it's probably off by 1, but whatever, I don't care, right? But these are basically the segment tree, and then in each node, so if you kind of think of it this way, you have 2 times n nodes, right? Basically, basic complete binary tree type kind of things, right? I'm not gonna go over binary tree in this problem because like I said, you should watch a segment tree video if you really want to get in detail. But the core idea that I always think about is that there are only 2 things that you have to think about for these segment tree problems, assuming there's no lazy propagation. This is a basic one per se, basic for segment tree, but it's simple but not easy, right? Like the ideas are fine, but the idea here is that, okay, let's say you want to do some queries. Let's say you want from, I don't know, yeah. Actually, let me redraw this real quick to use real numbers, right? So let's just say at the top we have 0 to 10, right? So then here you have 0 to 5, here you have 6 to 10, and then you have I don't know, type working rule is fine, but right? So you have 0, 1, and then this is just 2. Technically you could write 2 twice, fine, but you get it anyway, right? I'm not going to draw an entire thing, but the idea here with queries is that you're always just, if you're querying for a range, like let's say 1 and 6, say, right, then you're going to essentially binary search or binary traversal the tree to kind of, actually I didn't draw that part, which is a little bit sad, right? So this is 0 and this is 1, all right. Right, so you're gonna traverse, and of course there's only log n traversal for the left side, and then a log n traversal on the right side, right? What is it, 6, 8, let's just say 6 and then 7, 8, I don't know, right? And then you traverse on this side, and then you kind of just merge the results together, right? And how do I merge the results together? Well, yeah, so there are a couple of things you have to construct for this problem. You have to construct and update. First, we'll start with a static tree with a query, so we don't do updates yet, right? Well, then how do you do it, right? Well, first you build up this tree, right? So what does this mean? So you just have to define what each node contains in this segment tree, right? So for each node, for example, for one node, what are we looking for, right? Well, we're looking for this particular problem, and this is the hard part for this problem. But for general segment trees, actually, like for example, you can imagine that the most basic segment tree is a max segment tree, right? Then for one node, for the range of 1 to 1, the max is just, well, the one element that you have. And then you can imagine that, I can't go back without erasing, so it's a little bit wonky. But yeah, you can imagine that, if you kind of merge, as you kind of go back upwards, as you go back upwards like this, you're on this node, and this node, you just kind of take the results from the two child and then merge them together. And for a max tree, well, if you know the max for the left subtree and the right subtree is just a max, right? And then again, you traverse up, and then here you take the max of the left and the right, and so forth, right? And then now, and then it just goes all the way, yeah. And of course, just to kind of, and that's to construct a tree, right? If you do a query, you see you want to get a range from 1 to 6, then what happens? Well, you find 1, and 1 is fine, and then you kind of go up. And then you merge, but you know that, well, the 0 node is outside the bound, so then it just gives you, like, I don't know, negative infinity or something like that, something that when you do a max, it doesn't affect it, right? And then you just kind of keep going up, also bubbling that way. So then that's how you do merge. If you have elements that are bounds, you just return negative infinity, and then you just sum up all those things. But keeping in mind that everything I said, you only go up and down the tree, on the left side and the right side, I suppose. But that's just 2 times log n, right? And you will always get your answer that way, because it's just easy max functions, right? So okay, so that would be the max tree. But for this problem, how would we convert this, right? And I kind of knew the idea, or I knew that I wanted to do this initially, but this took me a while to figure out. Though I did barely get it in, but yeah. But I go, okay, and honestly, even when I wrote it during the contest, I did not have a clear definition of what should be in each node, which was my mistake. I just thought that I could probably kind of finagle a little bit, and using it as, honestly, part of the exploration. Like I was like, okay, if I play around with it, I figured that I could play around to get the answer, but maybe I could have done a better job of defining it more clearly from the get-go. But also, honestly, that comes from experience and a lot of practice. That practice will build you the experience. And honestly, I do not have experience in SegTree. Everything I described to you so far are the basis, and maybe a little bit more, but not that much more, are the basis from which I was built from. I'm like, okay, I have all these things, everything I just told you, that's all I know so far. How do I merge them in an interesting way? And because I don't really have all these patterns or whatever for SegTree figured out, this is how I worked it, right? Anyway, so it turns out that for each node here, instead, you take a similar idea from Q3, hopefully you saw Q3 already, which is that it has to be very precise, but I did not do this precisely when I first thing, right? Which is that, for each node, let me actually, if I want to clear it, I need more space though. So basically for each node, let me put this right here, L dot 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 all the way to L to right, we want to store K values where, yeah, I mean, it's just going to be X mod K, where it contains the number of subarrays that ends at R, right? Number of X, what do they call it? X value or something like that, right? And again, if you kind of have this visualization, which by the way, you should, maybe I should mention this earlier, go over my Q3 review. But basically here you can kind of visualize this as, having a segment from L to R. You have actually a lot of subarrays, right? Where you have, well, this entire subarray, you have this subarray, you have this subarray, you have this subarray, and so forth, right? So that's L and R, right? And you kind of compress all these subarrays into K values, right? K values of X mod K as the remainder. And that's basically the idea, right? That's how I did it at first. That part actually wasn't so bad. Still took a while, right? To set up the base node values, right? So that's how I set it up. But then the merging step is a little bit trickier, but not so bad, right? Because then now, if you have this visualization, which I was a little bit lazy on, then how would you do it? Well, actually, let me erase some stuff. Yeah, let me just erase most of it, actually. Actually, let me cut this part away. And then erase the rest. Right? So basically, I have this thing I have this thing, right? Yeah. And then now, but this is one of the nodes, right? So let's pretend this is one of the node. Okay, draw it again now. You have one of the node, and then now you have another node, and then that node also has its own. Actually, I'm just gonna copy and paste, right? Because I'm a little bit lazy today. Right? So like, let's say we have these two nodes, and we try to figure out how to merge them in a good way, right? And this part, if you watch the live portion, I wasn't very clear on because I didn't draw it out. I didn't have a visualization, honestly, right? But the idea here, and I thought that you could maybe like merge them in a way, but that's because I did not define this clearly and I did not visualize this. I did not understand that I had to go all the way to R, right? And so how would you merge this? Well, the idea apparently, and I have to kind of give me a second. I have to be really precise because I don't want to say the wrong thing. But yeah, so basically what do you want, right? As part of the merge. Actually, let me move these two balls down a little bit more, right? So what do we want as part of the merge? Well, we want part of the merge to be like a new L and new R. Let me use a different color, right? Right. So now we have bigger L, bigger a pink L, a big R, and this used to be let's just say let me add a thing about it. Let's just say sub n, right? And yeah, and what this composed of is, well, the previous thing, right? So this is L R from the left side, and then L R, they're on top of each other from the right side, right? And then now if you kind of look at all these lines, then now you go, okay, well, what do we want? Well, we want, we know what we want. We want these lines, right? The count of all these things. But how do you get it from here? From these nodes, right? Well, and that's basically, honestly, that's basically the idea, right? Is that, yeah, did I do it wrong on the code? Sorry, man. This is very weird because I feel like, oh. I messed this up. That's why I drew the visualization wrong. Okay. Everything I said is mostly right, honestly, but I drew the visualization wrong on this part. So my apologies for wasting your last 3 minutes, but I think most of the ideas still hold. It's just that's why my confusion, right? So, okay, let's redraw this ball real quick. Sorry, I feel really bad about it. That's why I was trying to be precise, but then I think I don't know. It's a very hard problem for me. Sorry. Right. So again, let's redraw this. That was not what that's what I mean by you have to define this precisely, but that is not what we want. And what I mean by that, right, is that for this array, we want different things. It's not what I said, because here we can assume that because you only get rid of the suffix, right, for this problem. So actually what you want is not what I drew, but similar but opposite almost. Similar but opposite, which is that you want here, these are the subsegments that you want actually, right? Why? The reason why you want these subsegment is because it implies the removal. Sorry, friend. Sorry. Larry makes mistakes, but I'm doing these live, so you know. So yeah, because you're removing this chunk, you're removing this chunk, you're removing this chunk, removing this chunk, and so forth, right? And then now, again, going to copy and paste. You have the left side and the right side, right? Oops. Maybe I could have. Oops. Okay, I have to copy and paste it more precisely. Okay, there you go. All right, close enough, right? So then now you're trying to combine these two, right? So how do you do it? Well, because you are trying to replicate. You are trying to basically replicate this pattern, if you will, right? So you want, what you want is actually this, right? Again, so then how do you kind of measure this, right? Well, the left side is pretty straightforward, right? Because the left side, oops, this side is going to be just the top half of this, right? All the way up to what? Let me change the colors again. Okay, let's say this side, and this time I'm correct. So let's say this side in pink. This side will just be, you know, we kind of draw the line. Then this will be the first half, right? Because, you know, you could just copy it over. And then for the second half, what does this mean? Well, here, for example, this one, we want to combine it with this one, right? The segment. And that's it, right? So that's how you, for example, let me change the colors again, actually. So yeah, for example, you have this thing, you want to combine it to here, and that will give you the first line, right? Again, this one, right? The second line on the right side, we combine it to here, will give you the second line here, right? So that's basically the idea, right? For this problem is that, well, then what do we need from each side? Well, for each side, we need this distribution, right, of the k, k values of whatever, right, of x, the kx values, I think they're called, right? Just like how many of these subarrays mod k in the product kind of way, and then to facilitate this merging easier, we have to get this. We have to keep track of this segment where it contains the entire, like one value that contains the product of everything inside the node mod k, right? And that's it. And then once you kind of merge it all up, I think everything is basically the same idea with a normal segment tree. This is basically the combined function. It's a little bit tricky, but that's basically it, right? Because when you do update, you just update one node at a time, and when you do update that node, then you just kind of keep on merging up in the same way, right? So all the merging, almost, there's nothing different from the merging and the combining as long as you have this. And that's really the core part about this problem. I know. I mean, even I made a mistake in the explanation and doing it the other way. But it's simple-ish, but not easy, right? I don't want to like make it sound like it's easy because, but I think once you kind of get everything what I kind of described in place, it is. I wouldn't say it's not that bad, but maybe leave a comment to let me know if that's true or not. I did like I say that as someone who took the entire time an hour and 8 minutes and to do it, but I had to debug something on the segment tree. I know some people have better templates. I don't know. Maybe I could have done that. But yeah, some people have better templates for stuff like that. But yeah. So yeah, first we'll go over the segment tree part. Like I said, I think I could rewrite this as like a better combined function, right? But this code, if you watch me solve it live, like I didn't have a clear idea of what I want things to be, and therefore it kind of is an evolution from that. Am I proud of it? Not really. But am I proud that I solved this one from scratch for some definition of the scratch? I feel proud enough. Like I don't know. It's definitely a very interesting one. But yeah, and I did not need. Yeah. Okay, let's go over the build function first, and you can kind of think of. I think actually, let me rewrite this live with you guys, guys and gals, at home, because I think we can make this cleaner, and maybe in doing so, we can go over it. I think I'm gonna give some credit to a couple of people on my Discord, on like Riff and what's an aptly named person segment tree, to kind of just this idea of using a combined function and a node, and maybe that'll make it clear. So let's do that, right? So here we'll set a node class that wraps around, and I don't know if it's too slow. Maybe it'll be too slow because I think I worry about that. But yeah, we can just set the value, and this is basically what we visualize, right? We set the value is maybe we just set to equal to 0. I don't know. It shouldn't matter that much, maybe. And then yeah, and then self.k value, k values is 0 times self dot. Oh well, I just got kv. K, right? Maybe we should put in a k, and yeah, right. So this is node value, and here we can I don't think I actually need this, and then we can define that. Then now nodes is equal to yeah, node with the k. You can't just do multiplication with these things because of memory reasons, but yeah, right. Right, and then now we build. Well, how do we build? Actually, for some reason, I don't know why. Sometimes I use 1 index, I use 0 index, but yeah, yeah. For this one, I use 1 index. Let's change it to 0 index. I don't know why I use 1 index, but yeah, yeah. So we set up the node, we built, and then build. Let's convert to I, right? I is just the index, and then basically this is segment tree stuff, and as I write it, I mean, we're gonna rewrite it, so it's fine. But if TL is equal to TR, that means that it is remember that TL and TR are the range of the range of the segment on that is stored on node I. The initial tree that we go through. Let me make sure that I'm on screen. Okay, so then now what we have, right? Well, so then self dot nodes of I, we'll set it to a new node, which is node of k, right? And then we set the value. Maybe we could actually set this a little bit more precise. Like we can make it as part of the setter is what I mean, right? So here, value, we have this, right? So then this can be v, and then yeah, if this is v, then Well, we mod it by k, and then here we increment this, and then we increment the v mod k, because now you have one instance, for this node of one value. Is this what I want actually? Maybe I lied. Hang on. I think we fine. Let's just define those two things, right? So value is v mod k, and then maybe k values. Then we just do k values, right? And maybe do it this way, right? And then on a build, we just create a new node, right? The value of the node is going to be array sub TL, because that's just the value of the thing, right? So value equal to this, and then we do a value, and then the kvs is equal to 0 times k, or self.k, right? And then kv of value mod self.k increment by 1, and then we just set it as the new node. We also mod this by self.k actually, right? Because this is the one node case, right? If you have one node, this is how we construct it from scratch. And actually, I do want to do a helper on this. So maybe we can just say create one node kind of thing. I don't know, right? Of some value k, or some value x, right? Or v for value. And then we have this thing. Then we turn node of value and kv, right? So then now self.node sub I, we're just going to be create self.create one node of array of TL, right? Because yeah, this segment only has one element, so we can just reference it from the array. Otherwise, we just built recursively. We built the left half and the right half. This stuff, I don't think I ever change in general. This is from my template. This is just to build the left half and build the right half, right? And then now this is the combination step. So maybe we should add a function here, right? Combine left, right. Okay, so now we assume they're nodes, so we can actually kind of, yeah, okay. I'll leave it up here for reference, for my reference, honestly. But yeah, from the left, right? So then now, what do we want? Well, so we need two things, right? The value and the key value, the k values. The value is just going to be equal to left dot value. Is that called value or wow? Times right dot value, right? Mod self dot k. And this is because, you take value is this val is going to be the product of the entire segment, mod k, right? So it's just the left, complete left and the complete right, and you multiply together to do a mod k. And then on the k values, right, is what we kind of did with the intersection. So let's think about it real quick. Okay, kvs is equal to right, sub.k, and then first you take, which order doesn't matter, but the left side, right? You take the left side. So for I don't know what's these. Like say sk for segment k in range of self.k, we take the left side, right? So kv of sk we add it to left of kv of sk, right? And then now we take it from the right side. Let me add a comment. From the left side, we just go all the way. From the right side, we want to combine it with the full left segment, and therefore it should be just self.k, oops, right? Then kv of and then you just kind of, from the left segment, you have left dot value times sk, which is for every k, right? So for that, we just add it to the right side, kv of s sub k. So basically, it's kind of like a shift. Oh, I have to mod it though. Right? Because and you could kind of work out small values in your head, but it's just basically, for example, you have the left. If the left side has, the left side is a 2, that means 2 mod k. Then now you times that 2 by every number on the right side, right? So that's kind of how this gets done, and then you just return node of val kv, right? Again, and that should be good. And then now instead of having this stuff, which is the same thing, honestly. Yeah. We can say self.node sub I is equal to self.combine self.node sub I times I didn't. Okay, let's convert it to I. And I use 0 index, right? So I converted to 0 index. So you have to actually do, this is +1 and +2, right? That's how you do segment tree. I mean, it is segment tree, but it's just a basic tree type thing, right? So that means that here we get the left node and the right node. You probably could have indexed it or alias it, right? So this is your build. You just combine and then that's it, right? Let me run the examples really quick just to make sure I don't have any one-time error, which I do have. Oh, I changed the. Where do I have that? Oh, here. Oh, I don't have to do this anymore. I could just write none because we always just create it, right? Oh, create one node. Let's create one node. Oh, I forgot to return include self because I'm a Python noob. Array is not defined. Okay, this is v. K is not defined in line 3. Oh, I guess I do need K. This is very awkward. No, I don't need K. I just need, okay. I just do it this way and then I just pass it in that way, right? Create one node. Okay, so yeah. A lot of silly mistakes, but I think this one's just a typo. Sorry, friends, that I'm debugging it live, but yeah, I mean, this is okay. This part we have to do the other things, right? So yeah, so that's basically your combine, and this is your build. So we're pretty happy, right? Yeah. So this is your build, right? And then now on update, it's the same idea. If you have one node, we update one node. So node sub I is going to self.create one node of I guess v, because that's what we updated to, right? And then everything else we don't have to care about because we are already doing it. Maybe mod self.k just in case. I think I already have that, but maybe not actually. We should also update these to be 0 index, as I said, I forget. Yeah. And then update again, this is +1, this is +2, that's fine. And then again, you have all these funky things, but you can also just write yeah, self.node sub I is equal to self.combine, and that's it. This makes it much cleaner, but as you can see, I solved it with a minute left, so I wasn't, I don't know, I guess my original template's not as clean as well, but hopefully this is kind of cleaner, right? So one again, okay, K tree, line 16, so we have to do the fetch. And yeah, so that's it for the update, right? So here we have one node, we update one node, or we create one node, sorry. And then this is essentially a binary search. We only update the position, so it's position on the left side or the right side. So we do that, and then we combine, right? You go down the tree one way, and you go back up, log n time, log n, things. The complexity, we'll go over the complexity in a little bit, but just to give you a sneak preview, combine is O of k time, right? So you have to do that math, but it's not O of 1 like it is often, but it's also not that bad, but yeah. And then now we have to figure out fetch, which is the same idea, right? So if the left side is greater than the right side, then this is an empty segment, or so then we want to actually return node of, I guess just this actually, except for one is in the beginning, right? Because this is the multiple factor, and yeah. And honestly, I kind of already did it this way, but yeah, if this is the entire segment, then we just return self of nodes of TL of I. Sorry, yeah, because we already have this node, so we just return it, right? Because we already defined it. The other one was I'll do some conversion of math. This is going to be slower than the way I wrote it but it is cleaner. Maybe it times out, but it should be better. But yeah, when we fetch, we want to fetch the left side and the right side, right? Keeping in mind that this can go out of bounds, which is why we need this to be precise. But once we do that, then the rest is actually pretty simple, as you can imagine. We combine it to left, right, and then we return it, and we are happy, right? We just fetch it from the left, we fetch it from the right. The tricky part about this is the base case, which I or at least I think so, because I struggle with it. But yeah, now the answer is a node, so this is a node. So then we want node dot kv maybe. Yeah, it looks okay. Ooh. Maybe I messed something along the way. Oh. My left right is probably not right because I didn't I remember I didn't update this. So yeah, we have to update to 0 index. Looks a little bit better. Let's give it submit. Hopefully it doesn't time out. It does use a little bit more memory than the other way that I have it, but I think this one is a little bit more cleaner. But I want to submit it just so that I could convince you a little bit better. Maybe it times out, and maybe that's fine. Oh, it actually accepts. But yeah, that's pretty much it, right? I mean, I think once you kind of realize that I rewrote it so that I take the combine function, everything else is actually very much the template. Like I don't think I changed much of the rest. It is just it is very standard segment tree stuff with no lazy propagation or anything. And yeah. And then for each query, we have the index, value, start, and x. The key thing of the start is that now we can get we want to the segment that goes from the start to all the way to the end, right? Because if you kind of, the way to think about it is, if you need a visualization, right, is that, and I'm trying to bring up the drawing one. If you kind of go back to here, if you are going from if you're going from a starting point, then you're just defining left as some random left, and then R as all the way to the end, because that's the segment that you're interested in, the end, so on. And that's basically the idea here. Update for each query, we update. We already talked about update. Hopefully that's fine. And then for each node, I fetch for each node from the start to the end segment, right? This is the segment that we want. The other is just segment tree stuff, and then this gives us the node that contains the value, a wrapper that contains the value, and then we append the x the remainder where the x is the remainder, and that's it, right? So what's the complexity here, right? Well, building a tree, it's all of n number of nodes. But there are all of n number of combinations, right? And you could kind of prove that, right? Because you have a complete tree on the bottom half of the tree. If you have n nodes or n numbers, then the bottom layer is going to be O of n, or n precisely, really. You have n one element nodes, and to combine them, it takes n minus one combinations, right? It's not even. You don't even need a binary tree for that to be true. It's just that every time you combine two items, you have one fewer item, so it takes n minus one combinations, right? And each combination takes O of k time, so it is going to be n times k as the construction, the initialization, right? And then for each query, we have an update. And for each update, we go down the tree O of n, right? You have O of k elements or O of k operations each. So it's going to be O of k times log n, right? For the update. Hopefully that makes sense. And then fetch. Fetch, we also kind of do it. It looks a little bit sketch, I concede, but keeping in mind that on the left side, this gets binary search on the left, this gets binary search on the right, so it really only does 2 times of log n, and as a result, it does 2 times k times log n number of combinations. Oh no, of operations, because you have 2 times log n combinations, and yeah, and that's it, right? So to kind of put it together, this is O of n times k time, and also O of n times k space, right? Because we have 4 times n number of nodes, say, technically 2 times n, but you know, they're rounding things, 4 times n, and yeah, that's gonna be the space. And here we have q queries, each one does log n time, and k times log n time, if you want to be precise. And also for space, I guess it doesn't, I mean, this is just O of q space, right? We don't really use more space. Technically we do, because we construct these temporary nodes. So maybe you could say this is at worst space. You could probably be better, but it's fine. I don't know. You get rid of these nodes. I mean, once you pop up the stack, actually, yeah, it's less than that, because once you pop up the stack, in theory, the memory's free. So maybe that's fine. No, but then it's still log n, right? So, okay. Probably, yeah. I don't know. It's close. But yeah, that is all I have for this one. Let me know what you think. Thanks for watching, and before I go, let's show the tree one more time, the segment tree, make it slightly smaller. There's your fetch, there's your node, there's your combine. I mean, I think this doesn't need to be function, I just need a helper. But there's your build, there's your build left, build right, combine, update, check with his left, check with his right, combine, right? And we have one node just created. And then I'll say the same thing for the left, right? Search for the left, search for the right, combine. And that's it. Yeah. And then this is the rest of the code. I mean, the rest of the code is just set up for segment tree. So yeah, that is all I have for this one. Let me know what you think. Thanks for watching. And yeah. Stay good. Oh, no. You could watch me solve it live in the contest now. Wasn't so good, but wasn't so bad. All right, let's go. Oh, this is Q1 or something? Nope, Q2. Nope, Q3. Maybe I just, okay, well, I didn't even know which one I looked at, but there is different though, so, okay, fine. Okay. Come on, that was such a, okay. Nums and a K, okay. 2D queries where you have, is this gonna be sig tree again? Index sub I, value sub I, so, okay, I don't know what that means, okay. Okay, so you get some sub array, okay, fine. The X value of nums were given, is the product, okay. We already did that, okay. But you're querying, you have to determine the X value of nums for X sub I. After, what is X sub I? Oh. Update num sub index of I to rise of I. Only this step persists for the rest of it. Does this not persist? Remove the prefix. For each query, they should tell us what a query is again. I don't know why this is so much reading. Okay, so you have this thing. Update index of I to rise of I. Okay. we move the prefix 0 to start -1, okay. And then what's x sub I? Oh, the x value of nums for x sub I. I see, that's where x sub I comes from. So for example, in this case, you have remove the empty suffix. Remove the prefix. Okay, fine. Where's the suffix? Do we still get to choose the suffix? What does this mean anymore? I think they just kind of put a jumble of questions together and hope people understand it, but it's still a little bit messy. All right. I guess that we can, okay, so we get to remove suffix again and then get the answer, and then nums becomes 1 to 2. And then we want to multiply 1, right? Why is this 2? Our number of ways, what? Okay, so this I don't want to understand this part. This is so much reading. All right, query 2. Okay, we update, and then empty prefix must be removed. Okay, fine. And then now these are the choices, so we can remove everything except for the prefix, or except for, I guess, not the prefix, but we didn't remove any prefix. So okay, we can remove the 3 and the 5. No, the x value has a different definition. Yeah, thanks. Still don't know what it means though. Number of ways to perform this operation. Okay, oh, I see. So there are 2 ways to get it to equal to 1. I see. No idea how to do this. Okay, so you want a suffix. And k is, oh, let me look at constraints, Larry. K is still only up to 5. Okay, so that part is true. Can we use segment tree? Okay, what does it mean? So we update, and is it a lazy update? We cannot remove prefix anymore, right? Because you only remove, okay, only any suffix, because prefix is this. Okay, so that means that starting from there, okay, if we want to do a segment tree, what would it even look like? So the nodes would contain, I mean, it should be straightforward in theory. It's, well, okay, maybe not, but I don't think it's easy, but it's simple, I think. It's just, each node, okay, and then we do a suffix of it. Yeah, I mean, I don't, okay, let's see. Let me find my regular segment tree template. Is this good enough? Oh, this is a long time ago, actually. It does a max. But what I want is lazy propagation, right? No, you don't have to be lazy. Wait, do you? I mean, how does it affect things? let's say you change a number from, I think it's just a shift, right? Because you change a number from, say, 3 to a 2, and only the mod matters anyway, but 3 to a 2, then it's like a shift of the previous values on the sub things. How do I mean, I get the idea, but I don't know how to quite implement it correctly necessarily. How much time do I have left? 1 hour. We have plenty of time, so we can definitely implement it without, let's say we implement it without the queries for now, and then we can do the update part later, just to confirm. I think this is the right way to do it probably, but it's not easy. What is n? N is still annoyingly big though. So that means that there's this times another 5, which is already a lot of space and time. Yeah, I mean, yeah, I mean, I think that's it. But it's just, I'm just not looking forward to writing it. That's all. Okay, so this is my basic segment tree, and do I have to do lazy propagation? I don't think so, but you just have to merge in a good way, right? What is M tree? M tree is the value. We want I've had this written another way before, but maybe not. Okay, M tree is the value, so maybe the K tree. I don't know. Okay, fine. None of this is easy, but it shouldn't be this hard. No one said it is hard. Do. What is M? What is M? I need to write comments for my code. What is M here again? Oh, it's just the initial value. I don't know why I have this actually. Okay, and then okay, so that part so far so good. This may take me the entire hour, honestly, and it's fine. It's part of the learning. It's just a very sad Larry times. Okay, I mean this recursively is fine, and then now, I mean this part is kind of fine, but it's also it's not K, but k is equal to raise sub v mod self.k. Okay. Right. And then now how do you merge? So this is going to be the sub array, right? Oh, this is just a build update. Max is fine. Okay, fine. I mean, max is wrong anyway, but okay. How do you merge? Well, first you sum up the two. Okay, that's fine. And then you merge them by taking the components. So every component in one part you merge it with the other, right? So okay, we could do that. M3 doesn't do anything. I don't know why I've stored it. We could just ignore it actually. I think that's just how I had it before. No, I mean it's I mean we can just write it this way maybe. We do want to store it, but we don't need to store it on each node. Right, we can update on the update. Okay, fine. And then merge, right? So then now is for left in range of self.k, for right in range self.k, right? So then now we have self.k tree of left of, what is re again? Re is the index. Why is re my node ID? Index. That's actually confusing, but okay, fine. But anyways, re times 2. So okay, so okay, yeah, I think that's right. So the number of things, so it's just a combinatorial thing, right? And then together, what do they increment? So okay, let's put it in a thing for now. And then increment should be left times right mod k. But for this node now. Yep. So this thing, we something like this, right? So that's the merge. Okay, let's do. This is one index. Why do I have one index once? I always confuse them. Okay, fine. Self dot k. Oh no, this is just return 0 is fine. Otherwise, we have this one node, the node being I, which we had recorded at v before. We could comment this out. Why did I comment this out? Oh no, it's just I didn't comment this thing. It's very confusing. Okay, so I is the node and v is the node here. Pass Larry. I gotta clean this template up. Self.k tree of x of I think that's right. Otherwise, so that's for one node. Okay, so yeah, this is the full node. Otherwise, we have to take partial nodes, right? Technically, R is always the suffix, but whatever, we can leave it in. Okay, so we have this, and then now we have to figure out how to merge. Just okay. I mean, I think that's fine, right? So same idea. No, it's not. I think you have to fetch the entire thing to merge correctly. Okay, fine. So then it is going to be 0. I did it this way because it has fewer objects creation. But it is a little bit awkward to write it this way. But it's fine. X for this for x in range of self.k. And now left is you go to self.fetch. This part we can copy and paste essentially. Okay, right? And now we do the same thing that we have here. Well, no, I mean, yes, but also no. Because then now you have two arrays and you're trying to merge them in a good way. Yep. Left of okay, right. I know mod. I forgot it in Q3. That was not great, but this one should be okay. Okay. Does this look good? Maybe. I know that I didn't do the update yet, but I think it'll be fun to at least play around with this for now. How much time to have? 49 minutes. So I took 10 minutes of it, which is not that bad considering. I don't know, considering that I'm so good looking. I don't know. I have enough things to say for that one. No, I don't know. Okay, so let's take about this, right? Okay, let's just make sure that doesn't have this. Is what I was worried about. Index out of line 31. K3. Did I do it wrong? It's K on the outside, which is CK, and then V on the out, right? Why is this out of index? Oh, it's out of index here, so array or sub V. Huh? Whatever, let's just do this. Oh, because V is one indexed. I think that's why. Yeah, it's a little bit awkward actually, but we don't use array again, do I? We use array again in update, just not yet. Oh, V is the node. It's not the node that is in the array element. How do I do this again? This is times 2. Man, I don't remember how the build works precisely anymore with the indexes. That's unfortunate, actually. This is not quite right. They're right. They're correct in saying that this is not right. One from 0 to n. No, I mean TL, right? So this should be TL. Okay. It's a little bit awkward the way that I have it here. Should be n-1 for inclusive. Okay, so it doesn't throw me an error, which is good. Good. And then now I just want to play around with some. How would I even play around with some? Like it inclusive, and then I have, I don't know, I just take the entire way. I just take the entire way to the thing. This definitely does not look right because it should have more numbers. Because this is just a suffix. Okay. That's sad, but okay. Let's see, let's print left, right. Okay, so suffix of 1, that's fine. The left is always 0, 0, 0, so that's why. That's actually not great. Why is that? I think I have some 1 index and 0 index weirdness, possibly, maybe. That's not great. Okay. LR. This is if there's 1 node left. Okay. Right. I'm just putting random stuff just to make sure. Okay. 0, 1, 0, 2, 3, 4. There's no 4, 4. No, maybe that's fine actually. Yeah. Am I doing something wrong? There's a smell in that. Maybe not, but 1, 2, 2 is 0. Okay, that's fine. 3 is 1, 4 is 2. I think it looks good so far. Yeah. Why am I not merging right? Okay, let's see. Oh, okay, that makes sense. Because I'm getting only the additional ones. But what I need to do is actually also sum the existing things, right? Do I? I mean, I do, but I have to do it in a clever way because it's suffix. So how? So you can't just. Can you? Or is it inclusive? Okay, let's see. Because you can't do the. Because it assumes removing prefix, right? So each node has to be defined as the number of nodes all the way to the right. Then that's how you merge the left side. But on the okay, I do have to be a little bit clearer on the definition. So then now, yeah, say 1001001, and that one represents that this node to the right side of the range. So then that means that you have to keep track of the count of things to remove. I think you only do one of the sides, but I think you only do this one because that implies that you get rid of the pre-suffix. Something like this. Does that look better? This one looks different. I have to remove some of my print statements. It's a little bit confusing now. $633, is that right? I don't know if this is right, but it looks more realistic. This one is still wrong. This one, I mean, it's not great. I should not remove this, that's why. But the other code is easy to write. Okay, the set should be right. I don't know why this is still 00. It's 00 because it's not part of the build, I suppose. It's on the merge. The right will always be on the right, so I think we don't have to worry about the T, or we just have to worry about how to merge them, I think. Yeah, but still no bueno though. Why not? Why not? Why not? Left is always 00. Why is left 00? left should never be greater than right though, right? So maybe that's not true. Oh, why? I black box some of this too much. Okay, so we want 1 to 4. Okay. So this goes to I don't know how to debug this. This is alright, L and R. I think my initial thing is just a little bit messed up with the indexing. We have 0 and 1. 0 and 1. 1 and 1. My indexing is so weird. Why is that so weird? Because you have 0 and 1, but L is still 1. So we just skipped 0, that's why the 0 index. But that's fair, that's fine. We don't want the 0 index number. But then when you try to merge the things, that's when you get wrong. Okay. Because this node left goes from 1 to 0, that's fine. But then it just returns 0, so I'm not merging it correctly as a result, even though we don't want that. We want just the right side, right? So, okay, so how did I prevent that? That's such a weird thing. Does that help? I don't know if this helps. Well, I guess it just expects to merge, but one, two, three, 6. This should be 10, right? So this is maybe 1. Why is this 12? Otherwise, this is starting to feel right, actually. from 2 to 4. But oh, it doesn't have to. I mean, it feels right, but you have to. I don't know. No, this is kind of right because you have to include the 3. You can only subtract that, so there's only 3 possibilities. So 1, 2, 3. This is only 4, so there should be at most 4, not 6, and definitely not 12, because you only remove suffix, right? So my merging is kind of wrong. Okay, how do you merge? I guess you don't do this, but I think maybe I just got confused because of this case. Maybe you do need something though. Maybe you do merge, but on the right. Maybe that was always the right side. You also need the other thing, I think. But 1, 2, 4. I mean, this is definitely wrong though. How do you merge? To merge, you have to first define what it is. What is a node? A node is the number. So each node, given a TR, is the number. Man, I don't know that I'm finishing in time. Half an hour. Okay. We wanted to go all the way to the end, right? So this means that now each node represents, it should be more the prefix though. I think that's why I had it the other way. Because it represents all the things that have terminated before you merge to the right. So then every possibility. No, so then it is just. So you have to keep track of the total of the region. I think that's it. Okay, so you do have to keep track of the sub-segment node value. That's how you do it. Okay, fine. I guess M3's revenge, what I had before. Go to M, I don't know. Just I forget what M stands for, but it's always how I had it. Okay, fine. I think I get it now. I just kind of got a little bit lazy on the math. But okay, so self.m3 sub v is equal to subsegment product. Right, yep, okay, yes. Which is just CK for this particular segment. And then now on the merge, this is not right, okay. On the merge, self.m3v is equal to this. Okay, so that's the self, but then now we want the left. So then now we want the left side would be no, it's just this. This is the count, and then the thing is just going to be just self.m3 of v times 2, right? And then you also add this to the thing. I think this part is now more right. I mean, this doesn't mean anything anymore because we have to update the fetch part first, right? I don't know, that was always a hack anyway. Okay, right. Okay, so then now, how many things go all the way to the end? Because it has to start at the beginning node, but possibly to the end, right? With a shift of these, and that's how this gets fixed. Okay, I think the build is right, but this part maybe not so much. Anyway, this would be left in either case. It is going to be, I guess, the same idea, or should be. The left side times the right side, and that would be good. Oh, it's not a V anymore, it is I. 1, 2, 3, 4. This feels closer, but definitely still some issues. 5, 5 has 1 subarray. This has 2. This should have 3. So there's something wrong, but we're closer. Okay, 1, 2, 3, 4, and then 0, 4 is wrong. There's no chance I'm finishing in 25 minutes, I don't think, but it's okay. Okay, 0, 1 has 2 numbers, okay. This one is not adding correctly. Why not? This is the left side. 0, 2. The left side has 0 and 1, the right side has this, so the total should not be this. This is the new thing, yep. Okay. It should be 2, so this should be shifted 2. But why? Is it just not? Oh, I got it wrong. I fixed it at some point and then I messed that part up. Okay. Okay. 5, 4, 3, 2, 1. Okay. 6, 5, 4, 3, 2, 1. Okay. I mean, this is just basic sanity check. I think this is probably more right. Okay. Silly mistake. At some point I keep changing back and forth that I confuse myself. Okay. Whew. But I think now I finally defined this problem correctly. Now I can do the update, right? Which is the most important part, I suppose. Okay. So what is queries again? Index value start x in queries. We want to update. How did I set it up? The node 0 and -1. Position is index. Value is the value, and then we want to fetch. I think I called it fetch 1, 0 and -1 from start and -1. And then that's it, I think. Okay. I mean, the update doesn't do anything, but I think we can have something like this for now. I mean, you could at least append something. Why is this appending nothing though? Oh, it does. It's just that. Okay. I mean, this is wrong, but because we don't do the update, but that's fine. Okay. So then, fine. Let's do the update then. Okay. If it's 1 tree, okay, then this should be very similar to. Yeah, I don't know why I use I and I use we in different places, and it's very confusing actually. Okay, so m.tree and then m.ktree of I don't have to do the delta anymore, at least. I think that's fine. We is 0 to 1. Do I have to reset stuff? I might have to reset stuff. Okay, fine. Okay. And then else is divide and conquer, right? We want to update left, update right. Okay, that's fine. And this is mostly fine. It's not quite fine, but it's mostly fine. I could copy this stuff. Not really, because the index is weird. So okay, so m3 of I is equal to. Oh yeah, okay, that's fine. Okay, and then now we have to do the rest of the update, which this is actually way or should be similar to build. We just have to copy and paste and also reset. I think that's the big thing. And then, come on, baby. 1, 1, 2, okay, not quite right. 1, 0, still also not quite right, and 4 is definitely not right. Am I indexing wrong? Then the 4 is particularly interesting, and also this one is also off by 1. They're also off by 1 in a lot of places. Okay. Was hoping. This updates the tree, right? Double checking this in my mind. The position, do we use position? I guess we don't necessarily. 18 minutes. I think I'm cutting it close. Maybe I have a chance if I could figure out what's wrong. I was hoping that this was already be it though. But it is what it is. Oh, because I have V here. This is what happens when you use V and I and you confuse it in a lot of places. Come on, Larry. I'm surprised that it didn't actually throw error. Hopefully that is why. Because I use V for value and I for the node, and I use the other thing for the other way. I don't know why. Okay. Okay, so at least this is still wrong, but it changed the answer, which I don't know, maybe that's fine. But yeah. 4 elements. How do 4 elements have 5 answer as to? Oh no, wait. Huh? Oh no, this is 5 elements. Okay. 5 elements. What are the third value is start is 0. So we start from start to n minus 1. So from 0 to 4. Still definitely should be 5. Oh wait, I'm silly. Of course that shouldn't be, but I'm not printing the right thing. It's fine. Okay, so this is okay. I'm more confident now, but of course it's not quite right. Right? X value is 1. The K is 2. What did this do? We update. Let's see. Let's say there's no update, right? Then what's the expected answer? The expected answer should be 2. Is that right? Yeah, no, 1, 2, 3. Oh, no. Answer is, yeah, that's right. 2 is right. So, okay, so the update is wrong, which we can fix, hopefully. The answer is, okay, so we update this 2 to a 1, so that's why. Did I merge one? Any more V's? No. Okay, that's good. Dummy. Why are you so dumb? I gotta make this consistent. It's just the I's and the V's, and I don't even use new variables. I just use dumb variables. All right, let's submit. That's just like a race too. And I was looking for it too, and I have to look for it again. If this times out, I'll be very sad though. Ooh, that's actually, I don't know if this is sadder, but it's definitely different. Okay, so we have 14 minutes. Maybe I won't solve this, but how did, was it 500 people gotten it? Man, I mean, maybe this is a known problem. I don't know it though, so I'm happy about that. 126. Does that change the answer? Nope. Okay, that's good. Because well, I mean, I don't know. Maybe it would have been bad too, but I know that I modded it. It's just, do I have it in other places? We have 4 arrays, right? We'll mod by K. Let me take a screenshot in case I don't finish. People really fast. I mean, maybe it's just a known thing. This 1 0 is very discerning, actually. Oh, maybe not, actually. Maybe it's the start is at 3 4. 3 3 2 2. Okay. 002 is not the answer. It is returning 0 for x is equal to 1. Okay, so mod 3 we have 0 0 1 1. The first one, that's a 2, right? So we set this to a 2, so 0 2 1 1. And that now we're trying to get a suffix product of 2. Which you can't because everything starts with 0, right? Why is there only 1? Oh, because it starts at 3, but me just muck around with it for a second. Because if this was 0, it should be all of them, right? Yep, okay. Just want to be confident about it. Okay, so then now set the first element to 2. Was it not already at 2? Oh, but it's 2 and okay, so it's 2 and 1. Okay, so this does nothing, but now we start at index 2. It is true. This is should have 2. Why is it giving me 0? That's not great. And I think most of my ideas are out, so like I don't know how to think about this anymore. Like other than minor typos, maybe. Okay. We have to figure it out. We only have to grind for 10 more minutes anyway, because if you don't know, you don't know. But okay, so 2, 3, 3, 3. This is the total. This is the left. Why is 2, 2 not? I have some weird things going on with the off by 1. Because the reason is because for 3, 3. No, this one's fine actually. It's this one. Okay, so we want to do Are we merging in a weird way? Why is TR so weird? I know enough to know some stuff, but I don't think I know enough to be not confused. Why is it getting me? Oh no, it's just. I think my merging is not right for LRTR. My merging is not quite right because it's trying to look at 0, 3. And then the left side is 0 because, well, it doesn't go for it. But I'm still shifting it by this. So I have to do like another if statement or something on the left side or here on the fetch. Fetch is very weird because I'm shifting it without we needing, like, we should not care about that segment, right? Okay, think. But then that should just be here, right? Okay. Because this is a very awkward segment to query, which is why it's wrong, because it shifts this part into here. But the left we don't care about. I'm not handling the space case right. Maybe my template is crap. I actually don't know. Maybe I don't remember it well enough. Did I mess up in some of the things? No. Why? Why is it doing 0, 3? Maybe I just don't understand it as well. So okay, 0, 3 wants to get 3, 3, right? So the left side, we should just ignore it, right? Why is it not? Instead, this shift is messing me up. This is 3, 3, 0, 3, right? I don't know enough segment tree variations to figure this out, I think. I could figure this out. It's just probably not in the next couple of minutes. This is the first query, okay, but then shouldn't it be just a lot of zeros? I don't get it. I think it depends on this thing being true with the left component, so then I have to maybe return the left component as well. Okay, fine. I think maybe that's what I have to do. The shift is 0, and then this returns self.m tree of I. Okay, left. Is it a shift? If you times everything by 1, is that a shift? That's not a shift though, but maybe it's a 1, so it doesn't shift. 91. Oh, because now we return tuples. Oh no, because this does not return the tuple, and this is now self dot. It's just left of 1 times right of 1 for this whole subsegment times self.k or mod self.k. Oops. Did I make it? 1 minute and 32 seconds. Okay, I got the right answer for this one. Got wrong answer for no, right answer for the other ones. Let's remove some print statements and let's YOLO submit. Is this right? I mean, this is wrong. I'm not gonna have another chance to submit anyway, unless it's really obvious what's wrong. So let's YOLO submit. We have a minute left to go on the clock. Hopefully I don't print anything excessive, I mean. Yes! Wow. I mean, it's not the best time, but it is a happy time with 51 seconds to go. Yeah, easy problems. I mean, that's a really ridiculous Q4 actually. I'm sure that if people have seen it before, I mean, I don't know. My guess is people have seen it before, and or just like it's probably like a CSGS problem or whatever it is, because it's too hard for people to solve in 10 minutes, I think, and or ChatGPT, I guess. But you know, but there was like some smart actual non-cheat, I presume non-cheating people who got up there. I didn't really see anything, but. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's problem, or this problem, this contest, everything in between. Stay good, stay healthy, good mental health. I'll see y'all later and take care. Bye-bye.